Testing. Good morning and welcome to today's webinar from Micrographics, Factory Design Utilities, not just for factories. My name is Aldred Boyd. I'm an application engineer for Micrographics, focusing mainly on the manufacturing side. So things like Inventor and AutoCAD Mechanical, Electrical, and of course the Vault to manage everything. So just to get started on here, just to take a quick look at the agenda, we're just going to go through what is factory design utilities. Now, many of you might have seen this, when you've got the product design and manufacturing collections, that's what the PDMC at the bottom there stands for. You might have seen that you've got this factory design utilities which you're able to download, but you don't know what it does, and you don't know how it can integrate in with your business. So hopefully after today, you'll get a better idea of what it can do and how you can integrate it into your workflow to better manage and maybe get out some designs a little bit quicker. Then we're going to take a look at which software utilizes the factory design utilities. So it's kind of like an add-in into the products that you will find in the product design and manufacturing collection. We're going to take a look at the layouts and space planning, the traditional workflows that we normally look at, or normally how we do layouts and space planning. And then we're going to just have a quick little discussion about the advantages of using the factory design utilities, and then how to maximize our product design and manufacturing collection with this factory design utilities that we have got. And then, apart from that, we can also take a look at just some opportunities outside traditional factory design. So, you think about conveyors inside a factory, where it goes to robots, other machinery that you've got, maybe some CNC machines. How do we best configure it inside a warehouse or inside a building? And I mean, that's kind of what we look at, say, factory design. But I mean, what else can we look at designing with this factory design utilities? And then just a little quick discussion on how to optimize your assets. We'll briefly discuss what assets are a little bit later. And then just a summary of what has been discussed. Okay, so just quickly, what is factory utilities? This is just the Autodesk definition, taken straight off the internet. Factory design utilities is used for planning and simulation of factory and plant layouts to increase efficiency. So once again, even in Autodesk's definition, we're talking about factory and plant layouts. Factory design utilities is used to create a digital representation of your factory layout. Once again, the use of the word factory, plant layout, but also digital representation. We've all really want to create something before actually going out and building a prototype of it. And if you can see that in 3D, it makes your life much easier down the line. Okay, so what software utilizes the factory design utilities? So not all the software that you have got in your product design and manufacturing collections will work with factory design utilities and have a little factory tab at the top. So on the AutoCAD side, you can either use AutoCAD Architecture, AutoCAD Mechanical, and AutoCAD MEP. So please note that normal AutoCAD will not have that factory tab, or will not be able to integrate with the factory utilities. So it is either one of those three over there. And then for the 3D portion, so that's for the 2D portion, as well as a little bit of 3D as well. So when I talk about a little bit of 3D, for instance, in AutoCAD Architecture, if you've never heard of AutoCAD Architecture, it's an AutoCAD-based architectural piece of software which works very much like Revit does. So what happens is you'll set up your walls, maybe a 270mm wall with a 50mm cavity, and then you'll be able to draw it. And as you're drawing and connecting the walls to each other, it will join it as it would in real life. Now, if I'm going to be doing a factory design or planning out a factory layout, I would like to also see the walls and where the doors are and the windows. So with AutoCAD architecture, what I can do is I can start off there, draw up my walls in 2D, and then when I do bring it into either Inventor Professional or Navisworks, then what you'll see is that we'll have that 3D representation of the wall. So AutoCAD architecture allows me to draw those walls in my 2D plan, and in the background it's building it up in 3D. And then when I say, for instance, bring in a door or a window, it knows that a door, when it goes into wall, needs to cut out the wall, so it'll cut out that wall and place the door, and I can move it left or right. And then as well as with a window, so with a door, the door will be situated at the bottom on the floor because that's what a door does. And then when I put a window in, it knows that a window can be placed in the wall. Obviously, it's got to cut out the wall as well, but then I can move it up, down, left or right, wherever in the wall, and it will also provide me that cutout in the wall over there. So, if you are looking at more of an architectural type of design, then I would say go for AutoCAD architecture. On AutoCAD MEP side, so MEP, mechanical, electrical, and plumbing. So if you are going to be, sort of need the outer design of your maybe HVAC or your electrical layout, maybe some cable trays, maybe plumbing, you can use that as well. And then you've just got your normal AutoCAD mechanical. So if you are using that for any 2D mechanical design, that will also fit the factory design utilities quite nicely. So that's on your 2D side. And then on your 3D side, then we go into the Inventor Professional. So with Inventor, once we've done our 2D layouts in AutoCAD, architecture, mechanical, or MEP, we can then flip it over to our Inventor or even our Navisworks, where it will then go and represent the 3D assets. We call them assets, like the blocks in AutoCAD, inside Inventor and Navisworks. And then just to round it all off, to manage your data and make sure nothing gets lost or anything like that, we've got our Vault Professional. Unfortunately, this will not work in Vault Basic, so you will need it won't be able to manage all the assets and the components of factory design utilities in Vault Basic. You will need to upgrade to your Vault Professional software over here. So let's talk a little bit about traditional design workflows. So normally what happens is, someone comes up, says, okay, right, so I've got the space and I need you to design my factory layout for me, or my plant layout. So what do we normally do? We just go through to AutoCAD. We've got our blocks that represent each of our components. We drag and drop them, we move them, we copy them, we rotate them, and we make sure that there's enough space in between each one so that we can fit the appropriate amount of machines or get the conveyor running and not being able to go over the space that we've got available to us. Problems with this is it's 2D and it's flat. Okay, so what happens is when we take this design off and we actually start building it, and okay, right, this is going to go up and down and left and right, and we've got other components in that 3D space, you're going to find there might be complications later on. And what happens then? We've got to kind of take it back to the design phase. And when we're in the build process, and we have to take all the build phase, and we have to take it back to the design process, things start to get very costly. So those design changes, can be a little bit difficult in 2D if you're looking at a 2D plan. But I mean, the space configuration where the problems are in 3D. So those are quite difficult. Collaborating with the other maybe architects or structural engineers, because maybe there's a structural beam that's coming in and your conveyor needs to ramp up, and it's now interfering with that. So now, how do you collaborate with that? If you're both working, or if I'm working in 2D and then maybe the architect or the structural engineer is working in 3D Revit, how do we easily see those design sort of clashes or problems that we're having in a 2D and a 3D environment? And as I said, there are high costs incurred when the clashes are detected in the build phase. So really, we want to kind of have everything sorted out right in the design phase, because at the build phase, now we're on tight deadlines, and the money's running out, and we've got to kind of make a plan. So what can we do with that to get rid of those kind of 2D problems? we can use the factory design utilities. And some of those advantages are, the first one is you can meet tight deadlines. You'll see here that it's asset-based design. So let me explain a little bit about assets. Assets are basically like your blocks in AutoCAD. And what it can do, it can sort of link together like Lego. So you've got these kind of assets, and it just very, very quickly allows you to build something up, to see the conceptual design, and then you can flesh it out for a working design a little bit later. We've got the floor. So that floor, if you know a traditional inventor, if you start sort of designing something, it just gets kind of put into space. It doesn't snap down onto a specific surface, which would be then your floor of your factory or your building that you're working in. So it's got this floor, which you can then also configure. You can work in both 2D and 3D, and it is very, very easy to use. So, you could, when it comes to training, then what you have is a little bit of training about, how everything is configured, how to create assets, but when it actually comes to putting everything together, it is quite easy to use. Okay, so on the floor, what you can do is you can resize it. So for instance, if something is maybe 10 meters by 2 meters or 10 meters by 20 meters, you can go resize the floor to be able to sort of show you exactly where you cannot go out, your boundaries. So if if you're designing something and it goes over the floor, you know that now you've run out of space, you need to start redesigning the configuration. You can also put a DWG underlay. So the nice thing about Inventor and AutoCAD is it works great together. You can, and in essence, what you probably would have done is you might get the floor plan from the architect for the building, and that's your DWG. And you can take that, bring it into Inventor, and then start creating the 3D models or the configuration with that DWG as your base. You can also create a solid floor from this. Okay, so it's quite nice that maybe when you do a section, you actually see what the floor is and how big the floor is as well. Maybe you creating this on the first floor, for instance. And then you can also reposition it. So you can reposition it up and down from your 0 axis. You can work in both 2D and 3D. Okay, so think about the scenario. So we've got something, maybe we've got we've got a conveyor, it's running along, or maybe let's take a look at HVAC. So with HVAC, we're running along, and then what happens is the HVAC has to go either up vertically, 90 degrees, or down. How do we draw that up in 2D? We're looking straight down from it. You can't really. So, what we would do is we'd start working in 2D, because that's probably the easiest way to do it. You copy, you paste, you rotate, and then if you need to now start doing sort of vertical modeling, then we can just quickly hop into our 3D, which is Inventor, take a look at it. Okay, great, it needs to go up, awesome, and then we can go back to our 2D. So you can quickly migrate from both your 2D and 3D to see exactly how the design's going, and just design where it's easier to design. If I want to design in 3D, I do it in Inventor. If I want to design in 2D, I will do it in AutoCAD over there. Then we've got our asset-based design. So, when you download factory design utilities and install it, what I would suggest is take a look at this asset browser and actually go through each folder over of what's currently sitting inside in the assets. And you'll be pleasantly surprised. There are a lot of things, in here. And just looking at the sort of main headings: architectural, automotive, building utilities, conveyor, general, material handling, placeholders, point cloud. Now that's quite interesting. We'll talk about that just now. Process equipment, retail, robots, safety equipment. Then you got your user assets and user cloud assets as well. So now, maybe if you just want to have a quick look and see if there's something that is inside the assets, at the top you've got a search. You got your search. Type in something like maybe cable trays. I did that the other day, and there's actually quite a lot of stuff for cable trays. So with that, you're then able to, it'll mostly be, it won't be downloaded yet, so it'll ask you to just download it, and then you can, once it's downloaded to your system, you can just drag and drop it into your drawing and start off with that. So if there is something that you think might be unique to yourself, go and type in maybe different words that it might be called, and then you'll see that there actually might already exist an asset for what you are doing at the moment. And if the asset does not exist, you can then still go and create it and then put it into this asset location over here. Now, with asset-based design, as I was saying a little bit earlier, it's kind of like playing with Lego. So, when we were a kid, we had our Lego sets. Even when we were adults, we had our Lego sets, and we kind of snap everything together so that we can make a design. And that's how factory design utilities works. You'll see over here on the right-hand side, I've got this yellow snap point, and it's telling me that the end point on the asset that I'm bringing in, the HVAC piece that I'm bringing in, is going to snap to that other part over there. If I had to drag it to the other side, then it would try and snap to the other side over there. And when we are creating our assets, we will then specify how it's going to be orientated. So we can see how we can then place everything together. And with this, snapping to endpoints like Lego, this is where the ease of use comes in. It's, you're just coming in and you're just dragging and dropping your components in and creating this design. The snaps will work both in 3D and 2D. So when you are in AutoCAD, you will also see those snaps coming into play and snapping to the different components in your AutoCAD blocks or assets. Then with the assets, they're also very functional. We got these functional assets over here. And what I mean by that, so in normal Inventor design, when we want to change something, we're going to go through to our parameters, our user parameters, we'll create names for them so it's easily identifiable, and then we'll either go and change the parameter individually, by typing in sort of a certain amount of, like for instance, the height over here, 2,000, 1,500, 1,850, or what we can do is we can make a multi-user parameter, and what that allows us to do is actually set what do we want the height to be. So I only want 3 heights, 1.8, 2,000, and 2,200. And what that allows us to do is that someone's not going to come and put in a value that is not standard of what maybe we've got in the stockroom. So we've only got certain lengths of maybe the leg that you see on this on the stand over here. Okay. And then with on the shelving, and then you can also drive it through iLogic. So if you're using iLogic, if you're not using iLogic, maybe take a look at that as well. It gives you more configurations, more usability, and allows us to get our different configurations or all the configurations that we want when we are designing the layout that we want. Okay. So how do we maximize our PDMC or product design and manufacturing collection with this utility? So first of all, you need to download it. Okay, so you download it and then you install it. And just before you install it, just make sure you've got either architecture, MEP, or mechanical. I'm running both architecture and mechanical. And what does this do for you? So when you start off, great, you'll see these walls I've got over here was actually an AutoCAD architecture element. So I've used the AutoCAD architecture sort of architectural module to create those walls, create the windows, create the doors. And then the objects on the inside, so you'll see these, I've got shelving on the left, I've got HVAC at the top there, I've got some other shelving over here, and then as well as a desk and a table at the bottom over there. So I basically brought in the one shelving, okay, configured it to be either 3 high, or 2,000 millimeters high, I think, a certain width, a certain depth, and then I just copied it using the copy array. Same with this shelving over here, copied array, and then with this, I also just did that. I did an array here with, I think, columns and just rows being 1. Once that's done, okay, we've created our layouts, conceptual design. That's kind of where we think we want it to be. Let's now take a look at it in the 3D. So what we do is we can go to Inventor. So there's a little button inside AutoCAD Mechanical, which said either send to Inventor or send to Navisworks. So once that's done, this is what it looks like. It populates your 2D asset, and you will actually see at the bottom here, there's the DWG that I've created. It'll populate it with the 3D module that you've got over there. And because the HVAC is HVAC, and I mean, it's not supposed to sit on the bottom, on the floor, it's got to sit a certain height above there, it shows in the appropriate place. Then with the shelving, the table, chair, and the other shelves, you'll see there that it is sitting on the bottom. Now, what you'll notice is with the walls, it's see-through. So, with your architectural elements, or from AutoCAD architecture, it'll be see-through. But as you'll notice in a couple of slides later, once I take it into Navisworks, I'll be able to see all the materials that have been put on there, etc., for a more realistic look. Once that's done, another way to enhance this whole workflow is to actually get a proper bill of materials. Now what you'll see over here is that I've just got parts, for instance, this warehouse shelf. That over there is just the components over there. So, and there are 3 of them. Now, if I wanted to get a full bill of materials, like exactly how many shelves I've got, the lengths of it, the legs, the cross beams, etc., and maybe how many nuts and bolts in, I would create different levels of detail with my model. So I have a simplified version, which would be one part. For when I'm placing everything, it doesn't bog Inventor down or AutoCAD down with all the computation it's got to do. So, we want to just do a quick conceptual design, bang, 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 bang. Once that's done, I can say, okay, right, take it to the client agrees with it, okay, right. Now we need to go to manufacture, we need to actually build everything. So what I can do is I can swap out the level of detail, go for a high level of detail where I've got all my nuts and bolts, etc. in that, and then I can run my bill of materials and I'll get a full bill of materials down to the very last nut, bolt, and washer that I want. Okay, take that information, export it out to Excel, and then give it to the appropriate people to go and start either buying those nuts, bolts, and washers and creating and cutting all my steel work, etc. Just another thought to this bill of materials. I mean, if I had to go do my 2D layout into the traditional workflow, we wouldn't be able to get this bill of materials. What I would then have to sit and do is go take a look at my layout. Okay, right, for this 2D block that I've got over here, what normally goes into that? And you're going to start, creating that Excel spreadsheet that you normally would do. Whereas with Inventor, at a click of a button, you've got all your components for that assembly and parts over there. What happens if we don't have a 3D model of it, or maybe you are working with someone else and they use a different CAD package? Okay, so what you can do is with the AnyCAD technology, we can bring in Step, Inventor, AutoCAD, CATIA, SolidWorks, Alias, ProE, Wildfire, and Creo, and NX. We can bring those models in and we can create it into an asset. And once created to an asset, then we can go and bring it in and start creating our factory layout or our design in the plant that we've got. So one of the things that as well, so it can either be a fully defined 3D model, or what you can do is if you've gone with your laser scanner, you've scanned maybe a piece of equipment and you were planning on creating a 3D model out of it, but you haven't had time yet. You can take that scanned point cloud model and make an asset out of it as kind of a placeholder. And then once you have created the 3D model of it, then you can then go put it in. Or maybe if you're never ever going to create a 3D model of it, but maybe it's equipment that is already currently inside the space that you're working in, and you just want to have it there as a to fit into the space so that you cannot encumber on that space over there. And the beautiful thing about modeling up in 3D, elevation and section views, automatic. At the bottom left over here, I've got my top view, front view, side view, and isometric view. If I had to do a section on that, that section will be live, because if I move the section line, it will update my section automatically. What would we be doing in the traditional sort of 2D AutoCAD? You'd have to go and manually create it out of your head, looking at what the 3D would be. And then what we'd also have to do is we would have to, if the section did change or you wanted a new section, you'd have to then go manually create it out of your head again. So one of the great advantages of having a 3D model is just seeing those section views live and also being able to move them and modify them on the fly.